In this video, let's integrate e raised to 2x into sin x. So we've got two functions in multiplication, and whenever we have such a case, we use integration by parts. For the success of integration by parts, we have to select the first function and second function properly. First function should be easy to differentiate and the second function should be easy to integrate. Here, let's select e raised to 2x as second function and sin x as our first function. So I'm writing f of x as sin x and g of x as e raised to 2x. We know that integration by parts says that integration of two functions f of x and g of x can be calculated as first function f of x into integration of second function minus integration of second function into differentiation of first function and whole dx. Let's put the values of first function and second function and see what we get. So we are going to get e raised to 2x into sin x dx as first function, which is sin x, into integration of e raised to 2x dx minus integration of e raised to 2x dx into d by dx of sin x and whole dx. Before we move further, we need to calculate two values. First is integration of e raised to 2x and the second is d by dx of sin x. Before we do any of these, let's call this equation number 1. Now we know d by dx of sin x. This is equal to cos x. And integration of e raised to 2x. So we know integration of e raised to x, that is e raised to x only. But here instead of x we have 2x. So you can use integration by substitution. So you're going to get e raised to 2x upon 2 plus c. So let's call this as equation number 2 and this as equation number 3. Now let's put equation number 2 and 3 in one and see what we get. So let's put 2 and 3 in 1. So we are going to get integration of e raised to 2x sin x as sin x into integration of e raised to 2x, which is e raised to 2x upon 2 minus integration of e raised to 2x, which is again e raised to 2x by 2. This constant c we will add at the end. So the next term is d by dx of sin x. We have it from 2 as cos x and dx. So let's rearrange the terms a little bit and call this integration as I. So I'm going to get I as e raised to 2x sin x by 2 minus, let's take this 1 by 2 outside integration. So I'm going to be left with integration of e raised to 2x cos x dx. Now this term for integration looks very similar to my original problem. So let's use integration by parts one more time here to calculate this value. Let's call this I1 and let's call this equation as equation number 4. So for I1, I need to calculate integration of e raised to 2x cos x. Just like the original problem, I've got two functions in multiplication. So I am going to use again integration by parts. And very similar to the original problem, I am going to select the first function as cos x and second function as e raised to 2x. In a minute you will understand why we are selecting e raised to x as second function. So let's use the formula for integration by parts and calculate value of I1. The formula for integration by parts says first function, which is cos x, into integration of second function, which is e raised to x dx, minus integration of second function, so e raised to x dx, into differentiation of first function, which is d by dx of cos x and whole dx. So let's find out the next equation. I have already calculated the value of integration of e raised to 2x dx, and d by dx of cos x is minus sine. So let's put these values here. So I'm going to get cos x into e raised to 2x upon 2 minus integration of e raised to 2x upon 2 into d by dx of cos x, which is minus sin x and dx. Let's rearrange the terms a little bit. So I get e raised to 2x into cos x by 2 minus these 2 minus when multiplied will become plus, and let's take this 1 by 2 outside integration. So I will get plus 1 by 2 integration of e raised to 2x sin x dx. Now does this term look familiar to you? Yes, it is our original problem. We are calculating integration of e raised to 2x sin x, right? So I can write this as I. So I can as well say that I1 is equal to e raised to 2x cos x by 2 plus 1 by 2 I. Right? And let's call this equation number 5. If you remember what our equation number 4 was, so in equation number 4, we were calculating the value of I, and now we have calculated I1. So let's put the value of I1 to find I. So I am going to get I as, after putting 5 in 4, I am going to get I as e raised to 2x sin x by 2 minus 1 by 2 I1. So that is e raised to 2x by 2 cos x plus 1 by 2 I. Now I can take this I to the left hand side and simplify. So I am going to get I as e raised to 2x upon 2 sin x minus 1 by 2 e raised to 2x. So 1 by 2 into 1 by 2 will become 1 by 4 e raised to 2x cos x minus 1 by 4 I. Now we can take this minus 1 by 4 I to the left hand side. So we are going to get I plus 1 by 4 I equals e raised to 2x by 2 sin x minus 1 by 4 e raised to 2x cos x. So we can write this as 5 by 4 I as, let's take e raised to 2x by 4 common. So I am going to take e raised to 2x by 4 common. So I'll get 2 sin x minus cos x plus c. So this 5 by 4 we can take to the right hand side. So I can write 4 by 5 into e raised to 2x by 4, 2 sin x minus cos x plus c. The 4 in numerator and 4 in denominator will get cancelled, and you will finally get e raised to 2x by 5 into 2 sin x minus cos x plus c. And this is the final answer. So we have finally calculated integration of e raised to 2x sin x as e raised to 2x by 5 into 2 sin x minus cos x plus c. I hope you understood how we have solved this problem. The solution of integration of e raised to 2x into cos x will be calculated just like this. You will first use integration by parts, and again you will have to use integration by parts one more time. So keep practicing. Let's meet in the next video.